Assalamu alaikum everyone. In this video we'll talk about data models. Okay, data models are used for modeling the data to give a structure to the data. Okay, data models will have a set of concepts, retrieval concepts, updating concepts, okay, that will help you to manage the data, that will help you to store the data, structure the data. It will also have a set of tools which will help you describe the data, which will help you know the relationships among the data, which will help you to impose constraints on the data. Okay, all these things, the data entries, the data descriptions, the data relationships, the data constraints, everything will be done using this data models. The modeling of the data, the designing of the data, okay, how we are going to store, that will be designed using what? Data models. As I said earlier, we have got different types, different formats for storing the data. Let's see. Data models are further classified into object-based data model, record-based data model, and physical data model. Object-based is further divided into entity relationship model. Object-based, first we'll talk about object-based. Object-based means what? The data will be stored in the form of an object. Object is nothing but a real world entity. Okay? Object is nothing but an entity or a real world object. Suppose for example, student, it's a real world object, right? That we are going to represent in the form of this data models using different formats. We'll study later on. Example, student is done, a faculty is done, or a college is done. It is a real world entity, right? That's what. So object-based data model, which is further categorized into entity relationship model. Next, we have got record-based model. Here, in record-based models, the data will be stored in fixed records. Okay, and in different styles. See, relational data model is done, hierarchical is done, network is done. This record-based data model is further categorized into these three different types. Okay, record means it is the data will be stored in fixed lengths. Okay, in the form of records. We have got different fashions of storing this. One is relational data model. We know relation means what? A table. The data can be stored in the form of tables. Tables will have rows and columns. We know this, attributes they'll be having, fields they'll be having. Then the next is hierarchical data model. We also studied about this. Hierarchical model means what? The data will be stored in the form of an hierarchy, level wise. Okay. Next is network data models. Links will be present between the data, between the records. Okay. The next is physical data model, divided into unifying data model and frame memory data model. Okay. The next point is, see, object-based data model can be used at the conceptual level, and also it can be used at view level. We saw this in the three schema architecture, the three level of abstraction, right? We have got three levels. One is the view level, or I can say the external level. One was the conceptual level. I'm not writing the full form. The other was what? The internal level or the physical level. I'll write the physical level. Right? So this object-based data model can be used at these two levels, view level and conceptual level. Clear? Record-based data models can be used at conceptual levels, whereas physical data model is used at the internal level, the lowest level, which is very complicated. We will be using physical data model at the physical level or the internal level. Okay, the lowest level. Clear this? Next, let's see some examples. See, this is an example of entity relationship model. This one here, if you see, student is an entity, course is an entity, right? So student takes up a course, and student has got different attributes. Entity will be having attributes, right? Student has its attributes. Student will have his name, he'll be having his roll number, he'll be having his address, he'll be having his phone number, various things, right? He'll be having his date of birth, many different things. So I listed some attributes. That is, the student will be having his name, student ID, or the roll number and the mobile number. Okay. Next, this is another entity, that is course. Course will be having its course name and the course number or the course ID, right? So these are this is an example of entity relationship model. This student and this is a course. These are two entities which is having a one-to-one relationship. Okay, one student can take up one course, if he's studying computer science, he cannot study architecture at the same time. Matlab, for example, I'm saying, if he's studying computer science, he cannot study mechanical at the same time. From the same college, he cannot do that. Okay, so this is an example for entity relationship model. We'll study this in detail in the coming. We'll study this in the detail in coming videos. Okay, entity relationship model and relational data model. We'll study these two in detail. Okay, the next is we'll see hierarchical model. This is hierarchical model. Hierarchical model will be hierarchical. Matlab levels will be having. If you see here, we have got levels, right? Level 1, level 2, can have many more levels. And the data here is represented in the form of a tree-like structure. Okay? This is the root. These are the childs. Okay? It's like it's in the form of parent-child format. Okay? Tree matlab upside down. This is the root and these are the branches, you can say, or you can say if you are saying parent child, so this is a parent and these are the childs. And every this hierarchical model will have only one single root. It cannot have multiple roots. Here the root is college. College will have different departments, right? And each department will have its own faculty, its own classes, its own timetable, its own what we say labs, right? Each department will have its own different HODs. Getting clear? And different students, each department will have its own students. That's why. So if for example we took this college, one single root. We cannot have one more root here. This is not allowed in hierarchical data model. Okay, next we can have the roots can have multiple children. Okay, suppose, and next thing, if this is a parent, for example, a parent can have multiple children. It can have one more children as well, one more child. It can have one more child. Not required कि आपके पास सिर्फ दो ही child रहना. Not necessary. ठीक है? So a parent can have multiple childs, but a child can have only one parent. Okay? It's in the form of which relationship? See, one to many relationship. Getting? This is one parent. It has got many different children. So one to many. Okay? One to many relationship. Also, suppose if I've got only one department, okay, you will say we have got one library. We are not talking about the departments for now. Suppose I'm only talking about a college which has got a single library. This is what now? One to one relationship. Getting? So a hierarchical model will have one to many relationship or one to one relationship. Okay. The disadvantage that we face in hierarchical data model is that, see, it does not allow, first thing, it does not allow many to many relationships, right? It is only one to many or one to one relationship. Okay? It does not allow many to many relationships. One drawback. The other drawback is that it is easy to design, but it is complex to implement. Okay, second disadvantage. One more I can say, if I'm going to update the data, it may lead to inconsistency in the data. Okay, updating is a little bit difficult. Data inconsistency or data duplication is possible in this structure. Okay, I may have, see, suppose department 1, so I can again have department 1. For example, I'm saying just, okay. So these are the disadvantages of hierarchical data model. Let's see next one, that is network data model. This is a network data model which wherein we'll be having different records which are connected with each other. This is a record, this is a record, this is a record. Clearly, if you see here, we have got many to many relationships. One record can be connected to many different records, and that records, many records are connected to many different records. Okay? So the drawback of hierarchical model is overcome here. It can have many to many relationship. Many ko I am indicating. Many ko will indicate with the help of a star, an asterisk. Generally, will indicate it with asterisk. So many to many relationship is possible in network data model. Okay. For example, I took the example of lecturers here. I've got one lecturer, two lecturer, three, so on, and number of lecturers I'm having in a university. It is possible that one lecturer can take up many different subjects, right? Right? Similarly, the other way I can say many different subjects are given to one lecturer, right? So many to many relationship is possible. Also, see, many suppose for example lecturer 1 is taking DBMS It is possible that lecturer 2 is also taking DBMS if you have got different departments of different sections. So one section ke DBMS ki teacher will be different and the other section DBMS teacher will be different. For example, I'm saying. Okay. Same way. So many to many relationship is possible. Okay. Or we can take the example of different vendors and they are selling different items. So the relationship between the vendors and the items or the products will be many to many, right? Many vendors will be selling many different items, many different products. Getting? So this the drawbacks of hierarchical model is overcome in this network model. Okay. But the disadvantage here, if we see, suppose this, as it is you can see it as a very complex model, right? It is difficult to implement, first thing, and secondly, it is difficult to update or make any changes. If I want to delete this DBMS, what happens? These relationships get disturbed, isn't it? So updation or deletion is very difficult here. Data manipulating the data is difficult here. Get it? So this is the major disadvantage here. Okay, next we'll go to the relational data model. This is the example of a relational data model. We are very familiar with this. Relational data model, relation means what? A table. Table will have a rows and columns, matlab fields and attributes. And the relational data model, why is it so popular? Means it is this model is simple. See, it is very simple. We can see and say it is very simple to understand, right? And it provides many to many relationships. It provides one-to-one relationship. It provides one-to-many relationships. Okay, this relational data model. See, suppose I've got we'll transform this entity relationship model into relational data model. Same example. We've got student, course, student name, student ID, phone number, course name, course ID. So student ID, student name, course ID, course name, mobile number. It is easy, right? Suppose if I want to update one more row, if I want to update the detail of one more student, I've got already 3 students. I've got different IDs for the students, different courses that they took, their mobile numbers, right? If I want to increase one more, if I want to add one more, if I want to update one more student, it is easy, right? Just all I need to do is what? Create one more row, insert it directly, right? And we have got different tables. So the one table will be connected with the other table. We have got many to many relationships. We have got concepts of keys there. We have got concepts of constraints. So relational data model is widely used and it is very simple. It is very understandable, easy to understand, easy to implement. Okay, clear? So this was just a brief introduction to the data model, different types of data models. We have got basically categorized into 3: object, record, and physical data model. These are used at different levels in the database schema. The 3 levels of abstraction, we have got 3 levels, right? It is used at different levels. And object is further categorized into entity. We have got an example here. Record is further categorized into 3 different types. Record based model means the data will be stored in fixed records, fixed formats, and in many different styles, in many different fashions. So these are the 3: relation, hierarchical, and network, right? And the other is physical data model. One is unifying and the other is frame memory data model. I'm not showing this unifying and frame memory for now. Inshallah, you people say me if you people want to know about unifying and frame memory. Inshallah, in the next video I'll show you. Okay, say me in the comment section below if you want to. Okay, so that's it for this video. I hope this topic is clear for you. Okay, we'll see the remaining topics in the next video. Thank you.